from Penguin Computing, Phil Pokorny. Phil.
Hello. So I am Phil Pokorny. I'm the Chief Technical Officer for Penguin Computing, and I want to tell you a little bit about Penguin Computing, tell you a little bit about what we're doing with AMD to help you develop and take advantage of the heterogeneous system architecture that's embedded in the APUs, and then a little bit about another project that we're working on that we call Power Insight, which a number of customers that are currently using our APU development platforms are using to actually give them insight into what's going on inside their servers. So Penguin Computing, just one quick slide. We were founded in 1998, 1999. We've shipped over 10,000 systems to 40 different countries. We primarily focus on HPC, rack mount servers. We also do IP data centers, a number of other disciplines. Big customers, little customers have all bought from Penguin at one time or another. In addition to the hardware, we also sell skilled clusterware, which was developed by Don Becker, who sort of invented Beowulf clustering, along with Tom Sterling at NASA. And we continue to sell and enhance that. We also offer a Penguin on Demand service where you can actually rent CPU cycles on a per core basis. These aren't like Amazon Web Service virtualized machines. These are actually real HPC nodes with InfiniBand interconnects. They give you really high performance, but you don't have to pay for the whole cluster. You just pay for what you use. And I encourage you to come down to Penguin's booth. We can tell you a lot more about that, along with a lot of other technologies that we're doing after this talk. So, heterogeneous system architecture. AMD, a long time ago, bought ATI, merged them, and spent many years integrating both a CPU and a GPU into the same die. A couple of years ago, they started the HSA Foundation to dramatically make it easier to program those combined CPU-GPU chips, to provide you with the tools to be able to take code and run it on the most efficient, the best platform for that particular code. The HSA Foundation at hsafoundation.org is a consortium of all these software vendors, IP vendors, and so on. Now, that's great, that's all the software, but it's not real until you actually put it on some hardware. And Penguin has a long history of working with AMD. We are now on our third generation of APU systems that you could use, that you can buy from us, that you can use to actually develop using HSA models and actually prove out your code, improve it, and take advantage of HSA as AMD produces new APU chips in the future. So here's a couple of brief bullet points about what is in our Altus 2A30 development platform. It's a single socket FM2+, which is the socket that the current Kaveri chips, which are the first chips to fully implement the HSA architecture. And when I say fully implement, I mean that the GPU and the CPU share a virtual memory model on a per process basis. So that means that when you build a data structure on your CPU and you want the GPU to operate on it, you just pass the pointer to that data structure to the GPU and it can follow all the pointers because it has the same virtual memory map. Your programming is literally that easy. There's no marshalling of data, there's no copying of it to the GPU. The GPU accesses it in the same location in virtual memory where it existed in your CPU process space. The Kaveri APU is the first chip to actually implement that. This chassis has up to 4 DIMM slots, so we can put up to 32 gigabytes of RAM. How many of you have GPU problems that don't fit in the 3 to 6 gigabytes you get in a modern full-size GPU? Wouldn't you like to have 32 gigs of RAM to be able to feed your GPU? Huh? Is it no, it's DDR3, but it does run at 2133, and if we cut it back a little bit, we can even overclock it to 2400 in some cases. This chassis does have room for up to 8 hard drives. We can put a lot of storage in there. It does also have these 2 fixed bays, which I'll talk about in a minute when we talk about Power Insight. This is a shot of the motherboard. Again, this is sort of the third iteration of this motherboard we've been using. It has 4 SATA ports down, which we can wire to those hard drive bays, as I mentioned. We can also put higher performance storage options, SAS HBAs, SAS RAID controllers. We can also do high performance interconnects. A number of our customers have bought between 16 and 104 node clusters of APUs, and those clusters, pretty much all of them, have InfiniBand of one form or other, either Intel TrueScale or Mellanox QDR or FDR on them. There is a by 16 Gen 3 slot in this chipset, which means that you will get the full performance out of the FDR InfiniBand, perhaps limited a little bit by the memory bandwidth, but still there's no I/O bottlenecks there. There are also, we have a number of 10 gigabit Ethernet interfaces that are an option, and Penguin offers Arctica network switches, which can dramatically lower the cost of 10 gigabit Ethernet in a cluster environment like this. multiple PCI-Express slots, generally high performance 2x8s, by 16 or by 4s for those networks. So, on to Power Insight. Power Insight is a product we developed in joint with Sandia National Laboratories to give them visibility into not just how much power does the server as a whole draw, but how much power is the CPU taking, how much power is the memory taking, how much power is that hard drive over there taking, how much power is the InfiniBand HCA taking. And we've added, it's a very modular system. We use a set of sensors and a main carrier board that has the analog to digital converters, so we can instrument a lot of different kinds of systems, all kinds of different power rail configurations. New for version 2.1, at the request of the Pacific Northwest National Lab, we've added the ability to actually measure temperatures as well, so we can do up to 6 K-type thermocouples. We've drilled out the CPU heatsink, so you can actually measure TKs, along with measuring how much power is going to the RAM, how much power is going to the CPU. It uses an embedded Linux controller based on the BeagleBone Black to do all the monitoring and analysis, so it's completely non-invasive. It doesn't impact any CPU cycles of the host system, and has an Ethernet port, so you can access all that data on the power collection and monitoring out of band through the Ethernet port on the BeagleBone. There are, however, though, a few connections between the host and the BeagleBone, so that the host and the BeagleBone can coordinate, so that the BeagleBone knows when maybe critical regions are happening, so that you're recording the power the power data for critical regions of code that you're looking to instrument. And as I said, we can also measure the power from a PCI slot, which means that in a full-size system with a full-size GPU like the AMD FirePro 9100s, we can measure the power coming in from the PEG connector, that 12-volt auxiliary connector, as well as the power coming in from the PCI slot to give you a view of exactly the total power of that GPU, and only the GPU, or isolated from the rest of the system. As I said, we're making direct measurements of the actual voltages and currents. These are not emulated, these are not based on approximate models of the operating points of the parts of the system. We put Hal-effect or current shunt resistors in line in the power rails. We're measuring the electrons sort of as they go by, counting each electron, measuring what the voltage is. And then we can do that at a relatively high sample rate, and this is not huge, but 1,000 samples per second is much higher than the typical sample rate you would get from, say, a PDU that may only give you one sample every 2 seconds at a quarter of a watt kind of resolution. We're going to give you milliwatt resolution. We're going to give you thousands of samples a second, up to 15 channels. And new for version 2.1, we'll have expansion boards where you can actually expand up to 60 channels of power measurement and the 6 channels of temperature, all in the same system. As I said, completely non-invasive with additional host connections. It's small enough. I pointed out those 2 little drive bays. That's where we mount Power Insight. Fits inside the chassis. There's wires that run out to the harnesses that all are inside the chassis. It doesn't interfere with the airflow. I mean, a 2U chassis is relatively roomy. We can't really sort of fit it in a 1U chassis, but it does fit inside the chassis, and then you can put that chassis back in the rack. So you're measuring the power of that system in its normal environment. You're not setting it out on a bench where the case is open and you got a bunch of wires hanging out of it, and it's clearly not in the sort of condition that it's going to be in the rack along with the rest of its peers. You can close the lid and you're doing your in situ testing. It's also affordable enough. It's only about $1,000 per node. Depends on the number of sensors. More sensors cost more, fewer sensors cost less. But you can afford to instrument an entire cluster. So we have, as I said, Sandia, Pacific Northwest National Lab. The University of Warwick in the UK has some systems. The University of Virginia has some systems. A number of other customers on either a bigger or smaller basis have instrumented complete clusters between 36, 16, up to 104 nodes. And that's all that I have, and I know that you guys want to get to getting that headset. Yes?
Is your system compatible with liquid cooling, or can be retrofitted for liquid cooling?
Yeah, so the question is our system compatible with liquid cooling, or could it be retrofitted? Yes, it can. There's nothing about liquid cooling that would prevent us from adding the sensors. What typically happens, though, is in those systems, there's not usually a lot of room to get to the power harnesses and to route the cables. A lot of times the liquid cooling systems I've seen are usually pretty crammed with heat spreaders or the liquid cooling loops. And the big challenge of using Power Insight in someone else's system is generally getting access to the power rails. So For instance, blade chassis are not really possible because the power is coming from the blade backplane, and we can't get in between those connectors. So we recommend that if you are interested, that you buy those systems from us. We have, in addition to the APUs, other processor options. We have a dual socket Optron motherboard and the other guy systems, and we've so we've chosen specific motherboards though that allow us to separate the memory power from the CPU power. So when you buy a system from us, you get a motherboard that's really sort of optimized for measuring the power using Power Insight. So we don't generally recommend that you try to retrofit another system. It's best if you buy it with it integrated. All right, thank you very much.
Thank you very much. Thank you, Phil.